Hello everybody, and welcome back to screencast number 9 for chapter 19. We've been talking about fossil fuels, and we left off at the end of the last screencast talking about the Deep Horizon oil spill that happened. Today, as I was starting to get ready to say, we were getting ready to move into the Arctic and see what's happening in the Arctic now that the sea ice is melting. And climate change has melted the sea ice in the Arctic, which has opened up new shipping lanes. And now nations are jockeying for position and hoping to stake a claim to oil and gas deposits that lie beneath the sea floor. They want to start offshore drilling in the Arctic waters. This poses several pollution risks because if a spill were to occur, icebergs, pack ice, storms, cold temperatures, and wintertime darkness would damper or hamper any response efforts. The frigid waters also make with the temperatures being so frigid, would slow down any natural breakdown of the oil. In the U.S., Arctic waters that are now open to oil and gas leasing, some sites are 1,000 miles away from the nearest Coast Guard station. The Obama administration approved that these leases could happen despite admitting that the infrastructure to respond to the major spill did not exist. The Natural Resource Defense Council and President Francis Bianchi, a member of the commission of Obama, set up to draw lessons from the BP spill and also posed the Arctic leases as a reckless gamble. They lamented that neither the administration, the Congress, nor the industry had improved safety measures in any meaningful way since the BP spill. Fortunately, pollution from large spills has decreased greatly in recent decades thanks to government regulations, and there have been improved spill response efforts, so that has helped. It's important to recognize that most water pollution from oil results from countless small non-point sources that contribute, and these are from oil from our automobiles, homes, industries, gas station, businesses runoff, roadways that have oil and tar on them, enters our rivers and our wastewater facilities, and that's being discharged eventually into the ocean. So oil can also contaminate groundwater supplies when pipelines rupture or when underground storage tanks containing petroleum products leak. Atmospheric deposition of pollutants from the combustion of fossil fuels exerts many impacts on freshwater ecosystems, and water pollution from industrial point sources have been greatly reduced in the United States following the Clean Water Act that we talked about in Chapter 15. Many solutions exist to address the non-point source pollutions. All right, let's switch gears and talk about hydrofracking because this poses some new concerns. Extracting oil or natural gas by hydraulic fracturing or fracking presents risks of water pollution that are yet not completely understood. One risk is that the chemicals, known as fracking fluids, could leak out of the drilling shafts and into the aquifers that people use to drink water. Methane may contaminate groundwater that's used for drinking if it travels up the fractures or the leaks through the shaft. Fracking sites also create air pollution as methane and volatile toxic components of fracking fluids seep from the drilling locations. Some of the unhealthiest air pollution that has been recorded in the United States was found to be far away from the nearest city in a little populated region of Wyoming, home to extensive fracking operations. Many residents of the area near hydraulic fracturing sites have experienced polluted air, foul drinking water, so more research is needed to assess the extent of such pollution and to quantify any health risks that might be present. Hydrofracking also produces immense volumes of wastewater. Injected water often returns to the surface laced with salts, radioactive elements such as radium, and toxic chemicals such as benzene that come from deep underground. This wastewater is often sent to sewage treatment plants that are not designed to handle all the contaminants and that do not regularly test for radioactivity. This has caused concern in Pennsylvania, our state, where a boom in natural gas extraction from the vast Marcellus shale deposit continues to send millions of gallons of drilling waste to the treatment plants, which then release their water into rivers that supply drinking water for people in Pittsburgh, Harrisburg, and other cities. So the problem just doesn't lie with the hydrofracking, but also the oil sands develop polluted water as well. And there's similar concerns that are being voiced about the extraction and transport of the oil from the oil sands. You've probably heard in the news about the Keystone XL pipeline. There's worry that if that oil were to spill from a leak in the pipeline, that it would sink into the area's porous ground and quickly reach the region's shallow water table. It could contaminate the Ogallala aquifer that we've talked about before. This aquifer provides about 2 million Americans with drinking water, and it irrigates a large portion of the U.S. agriculture. The pipeline was originally slated to cross the sandhill region of Nebraska, an ecologically valuable area that hosts most of the world's sandhill cranes, as well as other migratory birds. The government decided to regulate and TransCanada agreed to move the proposed route eastward to skirt around the edge of the sandhill regions and the Ogallala aquifer. And of course now the new proposed area that the pipeline is going is over the holy grounds and burial grounds of some American Indian tribes, and they're concerned about preserving that area as well. The pipeline leaks are a legitimate concern, as oil from the oil sands is more corrosive than any conventional crude oil. Recent leaks along the Kalamazoo River in Michigan, in a residential neighborhood of Mayflower, Arkansas, and in other locations have caused severe contamination. So the Alberta oil sands, they process and use immense amount of water in order to be able to pull up the oil from the sand, and this results in gigantic reservoirs of polluted wastewater. The Syncrude company's massive tailings, that's what they're called, a tailing pond, that is near Fort McMurray, Alberta, is so large that it's held back by the world's second largest dam. The problem that's been happening is migratory waterfowl will land on the water bodies like this and are killed as the oily water gums up their feathers and impairs their ability to insulate themselves. These water pollution impacts come on top of deforestation required to mine the fuels in the first place. Industry representatives have countered that the area of that has been deforested so far only amounts to 0.1% of Canada's vast boreal forest. They also point out that they are mandated to attempt restoration afterwards. Effective reclamation has not yet been demonstrated. Regions that have been denuded by the very first oil sand mine, which happened in Alberta 30 years ago, have still not been able to recover. So another problem as we move along to coal mining and we consider what happens with our systems in coal mining, it also exerts substantial impacts on natural systems and human beings as well. Strip mining destroys large swaths of habitats and it causes extensive soil erosion. It can also cause a chemical runoff into the waterways that is known as acid drainage. And this occurs when sulfide minerals in newly exposed rock surfaces react with oxygen and rainwater to produce sulfuric acid. The sulfuric acid will then run off. It leaches metals from the rocks, and in turn it becomes toxic. Acid drainage is a natural phenomenon, so it's something that does happen despite mining, but mining greatly accelerates the rate at which it occurs by exposing many new rock surfaces at once. So they've tried to regulate, of course, and the United States requires that mining companies restore strip mined land following mining, and that's great, but complete restoration is impossible. There are ecological modifications that are severe and long-lasting that just does not allow for growth to happen. On the good side, most other nations exercise less oversight with their mining than the United States does. And now let's consider mountaintop removal. This is really sad and I think one of the ones that bother me the most. And this is where they actually mine the mountaintops, and it has impacts that exceeds even conventional strip mining because countless tons of rock and soil are removed from the top of a mountain, and these materials can slide downhill. There are immense areas of habitat that can be degraded or destroyed. Creek beds can be clogged and polluted. There has been a loosening of the U.S. government regulations since 2002, which is enabling mining companies to legally dump mountaintop rock and soil into valleys and rivers below, regardless of the consequences for the ecosystems and wildlife and the local residents. So here is a picture that represents the mountaintop removal for coal, and you can see that the entire mountaintop peaks are leveled and filled in. There's a dump adjacent to the valleys. And shown here over many square miles, this is in West Virginia, so part of the Appalachians in West Virginia. This can cause erosion and acid drainage into waterways that flow into surrounding valleys, and it can affect ecosystems and people over large areas. Look at how sad that looks. They've deforested in order to cut down the tops of the mountains, so that's taking away our major carbon dioxide recyclers. It's destroying the landscape. There's no soil for runoff, so we're going to talk about flooding in these areas as well. And more likely you're going to get much more smog and pollution because you do not have the natural recyclers available. Okay, so we are going to stop at this point. We're 13 minutes into the screencast, and I will see you on the other side. We're getting very close to the end of the chapter, thankfully. Just a few more things to cover, and we will be done chapter 19. See you on the other side.